let's do this question. I just did it. My explanation wasn't like great, and I don't want to edit that, so let's do it now. You're given a string s and an array shifts, which is the same length as a string s. If you have an array like this and you have a string like this, you want to shift a 3 times forwards. So a plus 3 would be d. And then when we get to 5 here, we want to shift a and b 5 times forwards. So that'll be d plus 5 and b plus 5, and so on and so forth. So when we shift 9 times, we're actually shifting 9 to the result we had before for all letters. So we could do this with brute force. Go through the shift array and shift a 3 times. Then when we get to 5, we shift the first 2 characters 5 times to the right. And then when we get to 9, we shift the first 3 characters 9 times to the right. So that will take n squared time. Or we could calculate the total number of shifts per letter in one loop and then go through all again and actually do the shift, which it would take of n time. So let's do that instead. To do that, I need to make this array. 9 will stay the same here because the last character will only shift 9 times. Then you add 9 to 5 and we get 14. So that means we actually want to shift b 14 times to the right, and we add 3 to 14 to get 17, which means we want to shift a 17 times to the right. But then there's a problem. What happens if these were quite large? Because they can be. These numbers can go up to 10 to the power of 9. Then in that case, we want to wrap around the alphabet. So we have to take it modulus 26. Let's do that. So we need to calculate the suffix sum by going through for int I is equal to, starting at size minus 2, because I don't need to change the last one, I greater than or equal to 0, I minus I, to shifts at I is equal to shifts at I plus shifts at I plus 1, and then take that modulus 26. If I shift a 26 times to the right, I will get a back. So if I take 26 modulus 26, I get 0. And that makes sense. The reason why I'm doing this, I'm doing a modulus here and not when I actually do the shift, because these numbers can get quite large. The number can go up to 10 to the power of 9, and there are 10 to the power of 5 of them. So what's 10 to the power of 9 times 10 to the power of 5? Too large. So now we go through the string and modify it to say that s of I is equal to, well, I need to take the modulus here as well, because after I do the shift, the value could go over the range of a to z. So let's do s of I minus a, because the ASCII character for a is 97. So I'm actually doing 97 minus 97, so I get 0, in the case where s of I is a. So I'm just converting the range from a to z to 0 to 25. Once I've done that, I can add the shifts value and then take that modulus 26 and add back 97 to that, so it's the correct ASCII value, and then return s. Let's submit that and see. Looks good. Thanks for watching. Like and subscribe, and I'll see you tomorrow. Hopefully.